Welcome student. Last video I discussing the construction of quinhydrone electrode. Now in this video I start the working of quinhydrone electrode. How to working take place in the quinhydrone electrode in potentiometric titration. See working in this electrode it take place a redox reaction. A redox reaction. In this electrode the take place a between redox reaction between quinone quinone and hydroquinone quinone and hydroquinone quinone and hydroquinone. What is the redox reaction? A redox reaction means it take place oxidation and reduction. Oxidation and reduction. See here the redox reaction take place between quinone and hydroquinone. See this is the structure of quinone. Structure of quinone. Plus 2H plus ions plus 2 electron gives hydroquinone. Gives hydroquinone. Working of quinhydrone electrode is take place redox reaction. Redox reaction means reaction between oxidation and reduction. Redox reaction take place quinone and hydroquinone. This is the quinone and this is the hydroquinone. In this between it take place the means 2 electrons are gain. 2 electrons are gain means it take place the reduction. It take place the reduction. This is the reversible reaction. This is the reversible reaction. See simply this is structure simply see in this structure quinone plus 2H plus ions plus 2 electron gives hydroquinone. Simply quinone and hydroquinone. Write down the reaction question top in this reaction. See reaction question it is QA. QA is equal to activity of product. Activity of product is hydroquinone. Activity of H2Q divided by activity of reactant. Activity of reactant means activity of quinone into A square H plus ions. A square H plus ions. There are 2 H plus, that's why A square H plus ions. Then write down the cell potential of or EMF of quinhydrone electrode. Write down the EMF of quinhydrone electrode. Quinhydrone electrode. EMF of quinhydrone electrode. See how to cell potential or EMF of quinhydrone electrode is equal to E0 of quinhydrone electrode minus 2.303 RD upon 2F log of QA means this is the activity of hydroquinone and activity of quinone into A square H plus ions. This is the Nernst equation. Already told that Nernst equation. This 2 is the number of electrons take part in the reaction. That's what 2 means. In this reaction 2 electrons are takes part. That's why N is equal to 2. This is the EMF of quinhydrone electrode is equal to E0 quinhydrone minus 2.303 RT 2F log of action question. See hydroquinone is equal to, already told that hydroquinone quinhydrone, already told that quinhydrone is equimolar quantities of quinone and hydroquinone. already told that quinhydrone is the equimolar quantities of quinone plus hydroquinone. That's why activity of hydroquinone or activity of quinone is equal to 1. Is equal to 1. Already told that quinhydrone is the equimolar quantities of quinone and hydroquinone. That's why activity of hydroquinone upon activity of quinone is equal to 1. That's why what is the equation? E quinhydrone is equal to E0 quinhydrone minus 2.303 RT upon 2F log of means this whole value is equal to 1. That's why 1 upon A square H plus ions means this is the equimolar quantities of quinhydrone. That's why is equal to 1. That's why 1 upon A square H plus ions. A square H plus ions. That's why E quinhydrone is equal to E0 quinhydrone plus 2.303 RT upon 2F log of A square H plus means this denominator values goes to the numerator. That's why this minus sign is converted into this denominator value is converted into numerator. That's why this minus sign converted into plus. This minus sign converted into plus. See, E0 quinhydrone plus 2.303 RT upon 2F. This is the solve this equation 2 log of activity of H plus ion. That's why this two cancel. That's why E0 plus 2.303 RT upon F log of activity of H plus. Log of activity of H plus. See, this is the standard value. This is the standard value. What is the value of this value? E0 quinhydrone is equal to 0.6998 volt and pH is equal to already known that negative logarithm of H plus ions. Negative logarithm of H plus ions. Put up this value. This is the E quinhydrone is equal to 0.06998 minus 2.303 RT upon F pH means this is the negative pH is the negative logarithm H plus side. That's why minus pH. Then this solve this constant value get 0.6998 minus 0.0591 pH. This is the cell potential or EMF or potential of quinhydrone electrode. Then this equation used to determine the cell potential of quinhydrone electrode. In this equation, the EMF of quinhydrone electrode depends on the pH of the solution. Depends on pH of the solution. Means the EMF of quinhydrone electron depends on the pH of the solution. Now determination of pH. How to determine the pH of any solution by using quinhydrone electrode. म्हणजे quinhydrone electrode यूज करून एखाद्या सोल्युशनचं pH कसं कॅल्क्युलेट केलं जातं आपण बघणार आहोत. Then determination of pH. See, the quinhydrone electrode dipped in the solution of unknown pH. Quinhydrone electrode dipped in the solution of unknown pH, and this quinhydrone electrode coupled with another electrode by reference liquid, it is called as saturated calomel electrode. See diagrammatically, this is the quinhydrone electrode and this electrode coupled with another electrode, it is the reference electrode. It is used by saturated calomel electrode. This is the quinhydrone electrode. Quinhydrone, this is the solution of unknown pH. Solution of unknown pH. This is the quinhydrone electrode. This quinhydrone electrode dipped in the solution of unknown pH, and this quinhydrone electrode coupled with another electrode, that is called as saturated calomel electrode. Then how to calculate the pH of the solution? See the representation of this cell. See, E saturated calomel electrode, then solution of unknown pH, then quinhydrone electrode, then platinum wire only used for the electric contact. This is the representation of the cell. Saturated calomel electrode, solution of unknown pH. This is the quinone and hydroquinone. Then platinum, it is used as the, means here used the quinhydrone powder. This is the given or quantities of quinone and hydroquinone. Then how to calculate the cell potential? See, E cell is equal to E right minus E left. Then calculate the cell potential of this electrode. E cell means E cell is equal to E right minus E left. E right is the quinhydrone electrode. In this right side, this is the quinhydrone electrode. That's why E quinhydrone electrode minus E left. E left is the saturated calomel electrode. Then you already know that the E saturated calomel electrode is equal to 0.2458 volt. This is the standard value. That's why E saturated calomel electrode is equal to 0.2458 volt at 298 Kelvin. ह्या टेम्परेचरला E सॅच्युरेटेडचं व्हॅल्यू असते 0.2458. Then this value put upon this above equation. See, E cell is equal to E quinhydrone electrode already calculate here. E quinhydrone electrode already calculate here. This value put up means 0.6998 minus 0.0591 pH minus E saturated means 0.2458. Then is equal to 0.4540 minus 0.0591 pH means this and this minus this value is subtract from this value, get the 0.4540 and this as it is. Then here E cell. Then next E cell is equal to 0.5440 minus 0.0591 pH. You calculate the pH of the unit solution. That's why pH is equal to 0.4540 minus E cell divided by 0.0591. You calculate the pH of the unit solution. Means pH, this value is the positive that transfer this side. That's why negative means 0.4540 minus E cell divided by 0.0591. Or in general pH is equal to is U quinhydrone minus E saturated calomel electrode minus E cell divided by 0.0591. 0.0591. This equation is used to determination of pH of the unknown solution by using quinhydrone electrode. Means this equation is used to calculate the pH of the unknown solution by using quinhydrone electrode. Okay.